Hello everyone, in this video I'll be solving count pair sum in matrix. So in the previous video which you're getting on the I button, so there I have solved using brute force and one of the what do you say good approach, basically better approach you can say. In this video I'll be solving the optimal approach. So I highly recommend please go and watch my previous video and then you come back to this so that you'll clearly understand like from brute force to better solution and better solution to optimal solution I'm doing it. In the brute force approach we were using time complexity of n power 4 and space complexity of 1, basically constants. But in the better approach we use time complexity of n square and space complexity of again n square. But in this video I'll be solving time complexity of n square, but space complexity I'll be using as O of 1, which is constant. So let's try to get into the example. So I think pretty much you have gone through the previous video, so let me not go to the problem statement. Let me tell you the directly example. So it was said that like in the 2D metric 1 and 2, we'll have to take one value from A, one value from B, such that its value is equals to x, which is target. And in the first case, they have given x as 21. So now, and also they had said these matrices are in increasing order from left to right. And the previous row's last element is smaller than the next row's first element. So it is basically sorted in this way. You can also see here 2 is less than 4, 4 is less than 7, 7 less than 9, 9 less than 10, and so on. It is going this way. So, okay. So, we know in binary search, one thing is that let's say we have some element 1, 2, 3, 4, 5, and target we'll have to find it as let's say 4. So in binary search you'll go to the middle element and you do it like the target is less than or equal to you are doing it. So based on that you will be moving your left and right pointer. Okay, so in the same way what we're doing is, since we know there are no unique elements, there are no repeated elements element, being let's say like they have said in the example strictly as, yeah, they have in the example strictly as key element is in strictly ascending order, which means it is in strictly ascending order. So strictly ascending means a is less than this way, and non strictly means a is less than equals to b. So equal elements are not there, meaning we have a unique element only. There is no repeated elements. So one thing, if you observe, what we can do is we will take first element from this one and we'll take last element from this one. Okay, we'll try to sum them. 1 plus 20, which is equals to 21, and target is also 21. We have got one pair. So once we got one pair, we'll try to move this. So since they have given like we have non repeating elements strictly using increasing elements, so there's no way that one more pair with this one or with this 20 you'll get as target. Okay, that is one thing. So once you got the target, what you can do is you can forward the pointer to next element. Let's say here we're doing now 5 plus 20 if you do, which is greater than 21. Okay, 25 is greater than 21. So in this case, if you see, since it is greater and this is in decreasing order, like why I pointed it here, because we'll be summing up a and b. This is in increasing order and this is in decreasing order, so we'll be summing up them together, and if you find if any point this is greater than the target, so the decreasing element has to be reduced. So we'll point the pointer to the next smaller element. So in this case, if you see, that will be 5 plus 16, which is again 21. So count we had got first time as 1. Now one more pair we have got 2. So now if both are equal, so we can either decrease the pointer or we can increase the pointer. So in first case I had increased it, so let me again increase it here. Okay, now it is 6 plus 16. 6 plus 16 is greater than 21. It is 22. Okay, So if it is greater, we'll have to decrease the pointer, I mean reduce the value. So we'll be decreasing the matru pointer. So now if you see 13 plus 6, 6 plus 13, which is less than 21. Okay, this is 19 less than 21. So as you can see, the element what you have got to a plus b is less than 21. So less means if you try to decrease this pointer, this value will be still less than the 13 value. So again it will be lesser than the element. So we need to somehow increase this one a, so that we are getting answer as target. So we need to increase this pointer. We need to point to the next element. Let's say this is 8. So now if you see, it will be 8 plus 13, which is equals to 21. Okay, 8 plus 13 is 21. 21 equals to 21. We got the third element, third pair. I think you're getting what I'm trying to do. So basically it is unsorted, so we need to take advantage of that. We'll be pointing to the first element in the first matrix and last element in the second matrix. We can do it reverse way also. We'll be pointing first element of the second matrix and last element of the first matrix. We can do that way also, but let's follow one process. So we'll be doing this way. So I think pretty much you got what I'm trying to do. So let's try to code it up. Okay, so first what we did is we need to take n is equal to mat1 dot size. This is our n. Okay, next we'll take is I1 or let's take index 1. This will be pointing to 0. Index 1 will take 1, and next we'll take index 2, that will be pointing to n star n minus 1. Basically the size of the matrix is n star n. So last element will be let's say this is 3 cross 3, which is 9, and if you try to count this way, 0 1 2 3 4 5 6 7 8, so it is n star n minus 1. So that we're taking index 2. Now we'll try to find if index 1 is less than n star n. Okay, so index when it is going from 0 0 1 2 3 4 5 6 7 8, it should be less than n cross n, and index 2 is greater than or equals to 0, because index 2 is starting from the last element, so it has to be 8 7 6 5 4 3 2 1 0. So it has to be greater than or equals to 0. So I think you got what this while loop is doing. Now from the index, basically this is 0 1 2, this is we are taking. So actually if you see in matrix, it is 2 cross 2. So we need to derive this particular ij. So one of the method is that if you want, let's say index I1. Okay, so in that case what we'll have to do is index divided by n. If you do, that will give you the row value. Let's say index 1 is equals to 1. Okay, let me explain you. Let's say you are at this one. Okay, 0 1 2 3. So index 1 is equal to, let's say, 3. So in that case, if you divide index 1 divided by 3, if you do, I is equal to basically, so that will give you 3 by 3, which is 1. So row is 1, which is correct. This is 0th row, this is first row, this is second row. If you want j, that will be index 1 modulo 3, that is 3 modulo 3, which is 0. So again, if you see, this is 0th column, first column, second column. So this is the formula, you can use it to derive the ij from the index. Okay, so I think you got this, what I'm trying to do. So index 1 will be index 1 divided by n, and j1 will be index 1 modulo n, and I2, which is basically the second matrix index, that will be index 2 divided by n, and j2 will be index 2 modulo n. We have got I and j. from these one dimensional index we have got two dimensional indices. So one thing we'll have to do is we'll take A is equal to matrix 1 of I1 J1, okay, and int B is equal to matrix 2 of I2 and J2. Okay, one variable will take which will keep track of the number of pairs. So we'll take count, which will be initialized to 0. We'll compare if a plus b equals to x, which is target, which is given in the asked in the question. If that is there, we'll have to increase count. Else if a plus b, if it is less than x, meaning uh, this element plus this element is less than x, so we need to somehow increase it. So this is in increasing order, so we need to point the index 1 to the next. So we'll have to do here index 1 plus plus. Else there is one more case, like if it is less than, and less than wala case is here, equals to case is here, one more case left out is greater than. So that will come in else condition. If a plus b is greater than x, if it is greater, which means this one is in decreasing order, pointing in this index is pointing in decreasing order, so we'll have to somehow reduce this. So index 2 will be reduced, index 2 minus minus, here we'll have to take index 2. Once we come out of the loop, so we need to return this count. Let's try to run the code. So I think time limit exceeded. Okay, index 1 plus plus, index 2 minus minus. Index 1 divided by modulo I2 J2. Why is it taking n star n minus 1, which is correct? This is also correct. Index 1 less than n star n and index 2 greater than equals to 0. Correct. So if both are equal, okay, so the reason why it is going into infinite loop is that here is the condition. Like if you see, if it is a plus b, which means both 1 plus 20 is, let's say these are equal to target, 1 plus 20 equals to 21 target. But in this case, in for loop we have not increased any variable, we need to increase this variable, so we'll have to do index 1 plus plus. Let's try to run the code. Yeah, it got accepted. Let's try to submit the code. So yeah, as you can see, it got accepted. So see, the time complexity of this algorithm is basically O of n square. Reason being, let's say index it is running from 0 to n minus 1, and at the same time this is decreasing. So basically this one keeps on increasing and this one keeps on decreasing. At some point, let's say like it is basically 2 star n square, not n square, 2 star n. Like this pointer will be reaching to the starting, which will take n square, and this also will be reaching to here, which will also take n square. So it is 2 of n square, and space complexity is of 1. So thank you guys for watching the video.